Today we're talking about special right triangles. And with our special right triangles, there's two of them that we have. Our first one is a 45-45-90 triangle, and our second one is a 30-60-90 triangle. So any triangles that have those measurements are what we call special right triangles. So what we have with those is a special relationship with their sides. Okay, so we have a theorem that says in a 45-45-90 triangle, the hypotenuse is root 2 times as long as each leg. So over here, I have x times root 2, and then both of these sides are x. Remember earlier in geometry that we talked about how if the two sides or the two angles are congruent, then their sides are congruent as well. So notice this is 45 degrees and this is 45 degrees. And so this side and this side are congruent. It was called the base angles theorem that we had. So then you could use the Pythagorean theorem like we did a couple days ago to find that this side is going to be whatever your x value is times root 2. But since it's a 45-45-90, we can skip doing the Pythagorean theorem and go straight to our answer using that piece of information. So for example, on our first one that we have, both of our sides are 4. Now notice that we can check and see that both of our angles are 45 and this is a right angle. Okay, so if I want to find the y value, it's going to be the x times root 2. So this is going to be 4 root 2. Okay, then on our next one, notice we have the same setup. Our 45-degree angles on two of them and our 90 on the other. Our two sides across from the 45 match. So the hypotenuse is going to be root 2 times the side length. So 6 root 2. Okay. On our next one, we have the triangle is oriented a little bit differently so that our 90-degree angle is at the bottom rather than the left side, but that's still okay. This is 45, this is 45. This side is 3, this side is 3, so the hypotenuse, which is across from the 90-degree angle, is going to be the side times root 2. So this is 3 root 2. Okay? On the next one, it's a little bit different because of the fact that we have a root 3. Still the same process. Also notice that we have this side missing. Okay, so we have 2 missing sides on this one. However, you still go through the same process. So across from both 45s match. So our y value is going to be 5 root 3. Okay? Our x value is going to be root 2 times our side length. So 5 root 3 times by root 2. Well, this means that you have to remember how to multiply roots. When you multiply roots, you multiply underneath the root, okay, as long as there's the same root. So this turns into 5 times root 3 times 2. Well, 3 times 2 is 6, so this turns into 5 root 6. Okay? Now, the next one, we're going backwards. Notice I have the hypotenuse, and I want the two sides across from the 90-degree, or from the 45-degree angles. Okay? So, look at your picture above again. Notice to go from here to here, I had a root 2 and the number in front of the root 2, and the side length is going to be the number in front of the root 2 as long as this is root 2. So, this is 5 root 2, so it's going to be the number in front of the root. So this is just going to be 5, and this side is going to be 5. Notice both of them match because they're across from congruent angles. Okay? Let's have you try this next one by yourself. Okay, let's see what you came up with. This is 7 root 2. It's the hypotenuse. It's times by root 2. So I just want the number in front of the root, so it's 7. So both sides are 7, both AC and CB. Notice on this one I didn't give you variables to solve for, and same as the previous one, but our instructions say find the missing side or sides. Okay? So I want both of these. On the next one, this one's a little bit more complicated because I don't have a root 2 with my 4. So what I have to do is figure out a way that we go from x root 2 to x. Well, to go from x root 2 to x, notice the root 2 goes away. So to make the root 2 go away, to go from this side to this side, I have to divide by root 2. Or from this side to this side, I have to divide by root 2. Okay? So on this side, I'm going to take 4 and divide it by root 2. Now, you should have learned about this in Algebra 1. To get rid of the root on the bottom, you're not allowed to have roots in the denominator. So I multiply by 1, but it's a very specific one that I'm going to multiply by. Notice root 2 over root 2 is really just 1. When I multiply by 1, it stays the same. So 4 times 1 is still 4, 7 times 1 is still 7. So I'm not changing the value of it, I'm just changing how it looks here. So on the top, 4 times root 2 is just 4 root 2. On the bottom, root 2 times root 2, the roots undo each other. So I get just 2. The other way you could think about it is I could multiply underneath, so I would get root 4, but the square root of 4 is 2. So my answer for both of my sides is going to be 4 root 2 over 2, but notice I can cancel out the 4 and the 2. So 2 goes into 4 twice, so I get 2 root 2 over 1, which is really just 2 root 2. So this is 2 root 2, this is 2 root 2. Okay, so these are the ones with the 45, 45, 90. Now let's take a look at your 30, 60, 90 triangles. On the 30, 60, 90, notice your angles are not the same. So that means that you're not going to have two sides that are the same like we did on the 45, 45, 90. Okay, so for your 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg. So here's my short leg. It's twice as long as the short leg. And then the longer leg is root 3 times as long as the shorter leg. So I take this to here is root 3. Okay? So let's try some examples. Find the missing sides. So if I want to find this missing side, notice you can also do this in relation to your angles. Okay? So across from the 30 is the one that's just x. Across from the 60 is the one that's x root 3. So to go from the short side, which is across from 30, this short side, to go to the hypotenuse, I times by 2. You look over here, I'm multiplying by 2. So I do 4 times by 2, so this is 8. To go from the short side to the long side of the leg, a long leg, not the longest side, I times by root 3. So to go from here to here, notice I add a root 3. That there's a root 3 that exists. You're not adding it, it's being multiplied. So I'm going to take 4 and times it by root 3. So this side is 4 root 3, this side is 8. Okay. On my next one, it's oriented, it's flipped a little bit so that the 90 degree is on the bottom, but the one across from the 30 is the one that is just your x. Okay. So to go from here to here, from the short side to the hypotenuse, I'm going to multiply by 2 because it's twice as long. So 7 times 2 gives you 14. To go from the short side to the long side, long leg, I times by root 3. So this is 7 root 3. Okay. Now, on the next one, it's a little bit complex because we have a root in our short side. So notice this is across from the 30 degree angle, so this is our x value. So I'm going to do 2 times 5 root 3. Well, you have to multiply the numbers on the outside of the root. So I do 2 times 5 is 10, and then I keep the root as it is. So AB is 10 root 3. Okay. To go from this side to this side, remember in our previous two problems, all I did was multiply by root 3. To go from 7 to 7 root 3, I multiplied by 3. To go from 4 to 4 root 3, I multiply by root 3. So we're going to do the same thing here. So I'm going to do 5 root 3 times by root 3. Well, to multiply roots, you multiply underneath. So I end up with 5 root 3 times 3. But notice this is a pair, so it can come out, or you can think the square root of 9 is 3. So I do 5 times 3 on the outside, so this is 15. Okay, a little bit longer. Now, let's try when we have a different side given to us. Okay, so if I have the hypotenuse given to us. So remember in your problem, to go from the hypotenuse to the side, this side is doubled, so that means that this side is half. So if I'm going from the hypotenuse to this side, I'm going to divide by 2. Okay? So if I want to go from 22 to the short side, which is across from 30, right, I'm going to do 22 divided by 2, which is just 11. Now, this part from here to here is just like we did above on our previous problems. To go from the short leg to the long leg, I multiply by root 3, so I get 11 root 3. Okay. Let's have you try the next one by yourself. Okay, let's see how you did. To go from the hypotenuse to the short leg, I have to divide by 2. So 12 divided by 2 gives you 6. To go from this short leg to the long leg, I have to multiply by root 3. So I get 6 root 3. Okay? Make sure that you fix it if you got it wrong. Okay, our next one is a little bit complex again, because we have a root already given to us. Still the same process, just a little bit different. Okay? So to go from the hypotenuse to the short side, I still have to divide by 2. So 10 root 2 divided by 2. I simplify the 10 over 2 to give me 5. So I have 5 root 2. So this side length of CB is 5 root 2. Well, to go from the short side to the long leg, we still do the same process of multiplying by root 3. So I do 5 root 2 times by root 3. Well, to simplify this, you have to multiply underneath the roots. So I end up with 5 times 2 times 3. Notice I don't have any pairs underneath, so I can't pull anything out. So I end up with 5 root 6. Okay? So 5 root 6 is this side right here. Okay? Now, let's try the last one when you're given the long side. So we looked at when you were given the short side, then we looked at when you're given the hypotenuse. Now we're going to look at when you're given the short side. The long side. So we looked at the short side and we looked at the hypotenuse. Now we're given the long side. Long leg. Struggling. Okay, so this is our long leg. Notice it's across from the 60. So to go from here to here, if you notice back up in your drawing that we have, to go from this side to this side, I got rid of the root 3, so we divided by root 3. Okay? So here I do the same thing. Well, in this case, it's quite simple because of the fact that the root 3 is just going to disappear. So 5 root 3 divided by root 3. The root 3's go away, and I'm just left with 5. Then to go from here to the hypotenuse, remember you double its length. So I do 5 times 2 is 10. Okay. So this one is oriented differently again, but notice that the long leg is still across from the 60-degree angle. So to go from here to here, I have to divide by root 3. Well, if I divide this by root 3, the root 3's cancel, and I'm left with just 8. Well, to go from the short leg to the hypotenuse, I double the length. So I get 8 times 2, which is 16. Okay. Now our last one is a little bit more complex again because we normally want the root there on the long leg, but there's no root, so I'm going to have to divide by root 3. So if I do 8, I guess up here is good, 8 divided by root 3, that's just a mess up. Remember, you can't have the root in the denominator, so I'm going to multiply the top and bottom by root 3. Remember, root 3 over root 3 is just 1, so I'm not changing the value, but I am changing how it looks. So 8 times root 3 is just 8 root 3. And then root 3 times root 3, remember the roots, if they're the same kind of root and the same number underneath, that they just disappear. They undo each other, the squared and the square root. So I just get 3, or you could think the square root of 9, which is 3. Notice 8 and 3 do not have any common factors, so I can't do anything there. So this is our side right here, so 8 root 3 over 3. Okay? Then our last one, to go from the short leg to the hypotenuse, remember that you multiply by 2. So it looks weird, but it's not as bad as you're probably thinking it is. So I'm going to do 8 root 3 over 3 times by 2. Well, to help us remember, 2 is really 2 over 1 as a fraction. To multiply fractions, I do top times top over bottom times bottom. Well, bottom times bottom is fairly simple, so 3 times 1 is 3. On the top, remember that I multiply what's outside of the root, and then I multiply what's underneath the root. So the 8 times the 2 gives us 16. And then the root 3, and there's no other root here, so I just keep the root 3 as it is. Notice I have nothing with the 16 and the 3 that can reduce, so my hypotenuse is just 16 root 3. Okay? And that's all we have. So you need to memorize how you go from one side to the other, or memorize this picture with the x across from 30, the 2x across from the 90, and the x root 3 across from 60. And then for your 45, 45, 90, the two sides across from 45 are x, and the one across from the one that is the hypotenuse across from the 90 degree is x root 2. Okay? And then you'll be able to find all the sides of a 45, 45, 90 triangle, or of a 30, 60, 90 triangle, and you don't have to use the Pythagorean theorem, so it's a little bit quicker, which is nice. We always like shortcuts. Remember to go answer your questions, and then to make sure to write a question about the video.